All right, so we're going to start looking at financial applications of exponentials. So when we're doing financial applications, we're going to use a slightly modified version of our equation, just with some more financial terminology in it. So the new version looks like this. FV equals PV 1 plus I to the power of n. Okay, so you note that this looks similar. It's kind of got that percent increase built right into it, but it has an exponent, it has an initial value and a final value. Same conceptually. We just use financial notation and lettering here. So the FV stands for the future value. The PV stands for the present value. I stands for the interest rate. And I'm going to put in brackets here per compound. We aren't going to talk right now about compounding periods, but we will next lesson. And of course, interest rates always as a decimal. N is the number of times interest is added. Okay. Sometimes I also say this is the number of compounding periods, but we aren't really talking too much about compounding periods today, or at least for this lesson. Okay. So in principle, all of these mean the same thing as they did before, but now they have some financial terminology surrounding them. One thing that's important to note is the future value and the present value are relative terms to each other. So there are situations where the present value isn't necessarily the value of something right now in the present time. It means compared to the future value of some investment, usually. So let's take a look at this first example. Okay, so Alice got $500 for Christmas. If she invests that money at 7% per year, compounded annually, that's important. I'm going to underline that. How much would it be worth in 5 years? So for right now, all our questions are going to say compounded annually, which means interest is calculated at the end of each year. So 7%. So let's go through our values here. So our present value is the value of our investment at the beginning. So $500 is how much Alice wants to put away. Our interest rate is our percent as a decimal. 0.07. You could always just divide by 100 to get the decimal whenever you see a percent sign. And n is the number of times interest is calculated, and over 5 years it would be calculated 5 times because it's compounded annually. And calculate the future value, which would be the value at the end of the investment. Future value is 500 times 1 plus our I value to the power of 5. And we can use our calculators and punch that in. Do be careful with brackets and things like that. I really encourage you to make sure you're keeping good calculator practice and with your brackets and things like that with these questions. It's very easy to make a mistake, especially if you do this addition in your equation. If you do not put brackets in, it will not work. Okay, so we get $701.28. All right, so the next part of the question says, how much interest did Alice earn? So the interest earned is the difference between your final amount and your starting amount. So how much more money do you have? That's called interest. So interest has its own little equation. So interest is equal always to the future value minus the present value, which just tells us how much more money you have at the end. Okay, so in this case, it's $701.28 minus our present value, which is the starting investment value of $500. That's $201.28. So that's how much money Alice earned on top of her initial money that she put in. Okay. So another thing we can do is just like we can find initial amount for an exponential, we can find the present value. So here's an example. So your parents want to put money into an RESP when you were born. So an RESP is a special kind of account that you can get. This is called a registered education savings plan. So parents primarily, and I think grandparents and maybe some other relatives can put money into a registered type of account, and there's some like governmental help and subsidy kind of thing where the government matches some of the money you put in and things like that. And then the idea is when the child turns 18 or when they have post-secondary related expenses, so for university or college, then that money can be used to pay for those things. So it's kind of a way for parents or relatives to save for their children's education for college and university, because those aren't free, at least in Ontario. All right, so this question's saying, when you were 18, they want it to be worth $20,000. That's not enough to pay for 4 years of university, but that's still more than $0. Okay, so at the end of the investment life, they want it to be $20,000. So that is the future value. Okay, if the interest earns 5% per year, compounded annually still, how much should they invest when you were born? So it's asking what the present value, what the initial start value of the investment should be. And when you're 18, so we're looking at the time between when you're born and you're 18. Well, that's 18 years, right? So N is going to be 18. Our interest rate is going to be 0.05. That's 5% as a decimal. And our future value is going to be $20,000. All right, so let's calculate this out. Let's write it out in our format. So $20,000 is equal to the present value times 1 plus 0.05 to the power of 18. And just like when we're finding initial amount, we're going to have to calculate this and divide it over to the other side. So let's do that. We get our present value is equal to 20,000 divided by, and we'll take out our calculator, and that'd be 1. Make sure we do it in brackets here. 1 plus 0.05 to the power of 18. Make sure we close that bracket there. We should get 2.4066 or something. And it keeps going, but I'm going to leave that on my calculator, and I'm going to do 20,000 divided by that answer to get a more accurate answer. And we'll get the present value is $8,310.41. Now, whenever we're doing money-based questions, we always do 2 decimal places, even if they're zeros, which sometimes happens. We always write 2 decimals. All right, that is it for the introduction to our financial applications.